Hello and welcome to Cannon County High School Algebra 2. The last few days we've been talking about probabilities and how to find different sample spaces by using the counting principle, and yesterday we did permutations and combinations to help us find the sample space. Today we're going to put that together with what we learned earlier about how to find probabilities, and we're going to find probabilities using those permutations and combinations to help us count up all the different ways there are to do something. And because this is a little bit more complicated, we are going to take this in kind of two parts. Today is part one. I'm going to be working on IXL CC.5 today, but we are not going all the way up to 80% today. We want to take this a little bit more slowly because these problems are quite a bit more complicated than what we did last time. So, Mr. Lyon, I'm going to ask you to put your thinking cap on today, okay? Because this is going to be a little bit more involved than before. But the basic idea is still the same. We are going to be finding the probability of an event. And to find the probability of an event, you take the total number of outcomes of the event and divide by the total number of outcomes possible. And we are probably going to be using permutations and combinations to figure out these two numbers. Remember that you use permutations when order does matter, and you use combinations when order doesn't matter. So let's try one. Again, this is CC5. I'm just going to be going straight from the computer today to take a look at the kinds of problems that they are asking us to do. This one says, Sue and some of her friends are going rock climbing this weekend. In preparation, Sue purchased 8 sports drinks to bring, including 6 lime-flavored drinks. If Sue randomly chooses to place 5 drinks in the red cooler, what is the probability that all of them are lime-flavored? Well, the first thing to figure out here is, does order matter? Does it matter what order the 6 lime-flavored drinks are placed in the cooler? I don't think so. It doesn't say anything about order being important here. So I think we're going to use combinations to figure this out. And the first thing to figure out is the denominator. What is the total number of possible outcomes? So ask yourself, how many sports drinks does she have to choose from? 8. And how many of them is she placing in the red cooler? 5. So that means 8 choose 5. We have 8 possible sports drinks to choose from. We're putting 5 of them in the red cooler. And I'm going to switch back and forth between paper and the computer here so we can do this. So that means I think we've got 8 choose 5 in the denominator for this one. That's the total number of possible outcomes that can happen. There are 8 sports drinks to choose from. She's choosing 5. Now, in the numerator, we have to figure out how many ways that is possible. So it says, let's see, 6 of the drinks are lime flavored out of the 8. If Sue randomly chooses to place 5 drinks in the cooler, what's the probability that all of them are lime flavored? Well, how many lime drinks does Sue have to choose from? 6. There are 6 total, and we're going to get all 5 of them in the red cooler. So that means we've got 6, and we're choosing 5 of them. So that is the number that goes on top. 6 choose 5. Okay? And so we're going to figure out this combination and this combination. And use a calculator to help us do that. And if you don't know how to do that, look back at yesterday's video, because we're going to go a little quicker today on this. So I'm going to hit the math button, go over to probability, and I'm going to do 6 choose 5. And that gives me 6 for the numerator. And then for the denominator, it's going to be 8 choose 5. And that gives me 56. So 6 divided by 56. And on this section, they want you to round to the nearest 4 decimal places. So I have to take 6 divided by 56. And I get 0.1071. 0.1071. They want us to round off to 4 decimal places. So I'm going to go again back and forth here a little bit. 1071, and that's it. Okay? So you want to figure out the denominator, you want to figure out the numerator, divide them, round off to the nearest 4 decimal places. Let's try another one. Pam received so many flowers for her birthday that they wouldn't all fit on her desk. By lunch, her office was decorated with 9 flower bouquets, 7 of which were lily bouquets. If Pam randomly selects 6 bouquets to take home, what is the probability that all of them are lily bouquets? Well, this sounds very similar to the sports drink problem that we just did, but that's okay. We're taking this slow because they're going to get a little bit more complicated. So first ask yourself, for the denominator, for the total number of outcomes, how many flower bouquets is she choosing from? It looks like she has 9 to choose from, 7 of which were lily, but we've got 9 total flower bouquets. And how many is she taking home? 6. That means what goes on the denominator? Oh, before we even get to that, does order matter? Does it matter which lily bouquet goes first? It doesn't say anything about that. So I would think combinations are going to work again, not permutations, because permutations are what we use when order is important. Combinations are what we use when order is not important. So looks like we have 9 choose 6 for the denominator. So where am I here? There we go. On the denominator, I'm going to have 9 choose 6. And for the numerator, well, let's figure this out. If Pam randomly selects 6 bouquets to take home, we'll find the probability that all of them are lilies. Well, how many lily bouquets does she have to choose from? 7. And how many is she choosing? 6, because it says all of them are lily bouquets. So 7 choose 6. So on the numerator, we're going to put 7 choose 6. So let's give this a try again. 7 choose 6 is 7. And then we have 9 choose 6 at the bottom. 9 choose 6 is 84. We want to round this off to 4 decimal places. So what is 7 divided by 84? It's 0.083 repeating. 0.0833. 0.0833. So those first 2 problems were very similar to each other. Let's see if we can get one that's maybe a little bit tougher. And I said I was going to break this up into 2 days, so we're only going to get up to, I'd say, about 50%, and then we might stop for the day because otherwise this video will get way too long. Carmen and Kate made a list of 10 psychology experiments they want to try at home. Each experiment tackles one specific psychology topic. 4 of the experiments involve cats. If Carmen and Kate randomly choose 5 experiments to try over the summer, what is the probability that exactly 3 of the chosen psychology experiments involve cats? Well, again, are they talking about what order these have to go in? They really are not. So again, we're going to be using combinations because in combinations, order doesn't matter. So that's the first thing we need to know. The second thing we need to know is how many possible things can happen here? How many experiments do Carmen and Kate have to choose from? 10. And how many are they choosing? They're choosing 5 to try over the summer. So they've got 10 to choose from, and they're going to try 5 of them. So that's the total number of possible outcomes. 10 choose 5. So let's put that in the denominator. All right, so we've got 10 choose 5. That goes in the denominator. The numerator this time looks a little more complicated than the problems that we just got done doing. All right, let's see what we have here. If Carmen and Kate randomly choose 5 experiments to try over the summer, what is the probability that exactly 3 of the psychology experiments involve cats? Well, how many of them involve cats? 4. And how many are they choosing? 3. So one of the things we're going to have to put on the numerator is that we have 4 experiments involving cats, and we're choosing 3 of them. So that's 4 choose 3. So that's one of the things that we're going to have to put in the numerator, 4 choose 3. But we're going to have to put something else in the numerator also. Because look, we were choosing 5 experiments total. And how many have we selected so far? We've only selected 3. So we need to select 2 more experiments. Okay, let's go back to the problem for a minute. If 10, let's see, we're doing 10 psychology experiments, or 10 that they have to choose from. 4 involve cats. Let me ask you this, how many of them do not involve cats? Well, if there's 10 total and 4 involve cats, that means there's 6 that do not involve cats. And how many of those 6 are we choosing? Well, we're choosing 5 experiments total, and we've already chose 3. So out of those 6, we've got 2 more to choose that are not going to involve cats. So that means we've got 6 to choose from, and 2 of them are how many we're choosing. So there are 6 non-cat experiments, and we're choosing 2. So both of these have to be in the numerator. First, we're choosing the 3 out of the 4 experiments that involve cats, and then we're putting 2 out of the 6 that do not. Told you this was going to get a little bit more complicated. So let's figure out what these numbers are and see if we got it right. All right, let's do 4 choose 3. 4 choose 3. That's 4. What's 6 choose 2? 6 choose 2 is 15. And 10 choose 5. 10 choose 5 is 252. So 4 times 15, I know that's 60. So let's take 60 divided by 252. 60 divided by 252 is 0.23809. So I'm going to take that 9 and round that up. So 0.2381. 0.2381. .2381. And we got it. Okay? So we got up to 50. This is what I'd like you to do today. I only want you to see if you can get to 50 today. And then we'll worry about the rest of it tomorrow. If you want to try to go further, you can, but I'm going to make another video tomorrow that shows how to get from 50 up to 80. But these 3 problems are pretty close to the kinds of problems you're going to see from 0 to 50. So give those a try. They're not going to be as easy as before. They're a little bit more challenging. So it'll be interesting for me to see when I look at the IXL who's actually trying these problems, because these are not for the faint of heart. These you really have to pay attention to what you're doing. But you can do it. It's certainly within your ability to do these. So we will talk to you tomorrow. Thanks for watching, and good luck. Bye.